Hey guys, welcome to the QuantLab. The QuantLab में आपका स्वागत है. In this video, we will talk about some deeper aspects of algorithmic trading from a technology standpoint. Sometime back, I did a video talking about not obsessing over strategies, talked about few books, and essentially the idea was that why should we deep dive into learning aspects of it and learn markets as well as technology if you want to bridge it. You don't need to become a coder, but you need to understand the nuances of how things are working to be able to, achieve a balance between the areas. I know seasoned traders who are doing amazingly well. And once they want to get into algorithmic trading, they want to understand a little bit of these nuances and they're trying to leverage technology the best they can. So this video is for anyone who's interested in the tech aspects of it. If you want market conversations, I suggest you go to the strategies playlist and things like that, which I've talked about. And this is more of a tech deep dive. So without further ado, let's get started. So what I have today, let me just do, yeah, this is full screen. So what I have today is two images. One image is here and the other is here, and I will try to talk in detail about each. So the starting point for most conversations is some sort of a research and strategy, right? And we'll talk about how to get into it from a technology perspective. Yeah, yes. So what we're trying to do is do a research around strategy. So how do we start? We start by identifying some data. We do historical data analysis. We do statistical testing and we do some strategy validation, right? Along with it, once we validate strategy, we kind of do model development, which we can think of as the strategy, and then we try to code about it. Again, we'll double click into these processes. Then you validate the strategy. If it is valid, you do paper trading. You probably do risk assessment. And if it is unsatisfactory, you go back and repeat. If everything works, you to get into live trading and you monitor and optimize, you update the strategy and the end. Or, more of the loop continues. However, what we kind of want to get into is how and what essentially are the technology aspects. So let me get the right zoom for a second. Just give me a sense. Yes. So no. Yeah, I think now it's slightly big visible. Sorry about this. Yeah. So we should kind of wait to lock it in place. Lock. All right. So what we have over here in this diagram is there's an algo trading system, right? You have market data, you have data processing, you have trading strategy, risk management, order management, execution, and broker. This side, essentially the left side, is where all of the tech aspects are there. Now, what are the nuances when we talk about data processing? Really a lot, right? Depending on the frequency at which you are getting data, most people think that, you just need to get data using some API. Your finance will be good. Let's use some broker APIs and that will be nice. However, when you are building a system, you should build a very robust system. And by robust, I mean you should have in stock, instruments and systems in place that can handle your data. And that's where this part comes in, which is database technology. Now, what are databases? Databases are really technology elements and tools which are designed to store data. They can store and manage data at really fast pace, and you can use this to build your own, historical data setup. If you keep all of them in Excel files or CSV file over a period of time, what will happen is things would get slowed down because programming languages are not essentially great at doing file processing in large chunks, although there are technology specifics to that. I'm trying to limit it to the tech that we usually use, Python. So if you give Python like 500 MB of data every single time of run and expect it to operate and respond within a second, you will have hard time. So this part really talks about of the importance of having a database and a system that can help you manage the data and store it. There's also nuances as to understanding how to get the feed if you're operating at a really fast frequency, something like tick-based data, you want WebSockets and stuff like that. APIs are not a good call. A lot of people get stuck at that and causes slippages. Then you move on creating trading strategies. Now, although it says here data science, Python and R, I think languages is fine. But essentially, machine learning and data science is not you should limit to. You should limit yourself to everything under the sun that can be used to find a, alpha in the market. And alpha is really a differentiator. So anything which gives you the edge over the market, that's what you want to find. And it could be using machine learning and data science tool, could not be, could just be relying on charts, you could be relying on price action, completely onto you. Now the technological nuances are, if you're getting into data sciences, it's best that you talk to some core tech person, because trying to build your own machine learning models is a very, very detailed exercise. A lot of times people look at YouTube videos and see that, hey, this is a good strategy. Like I have done a neural network video and you can see the link somewhere here. It's a really popular video, been seen close to 8-10,000 times. However, I always say that that's the process. That's not the strategy. So every time you see a video which says how I used LSTM to generate 600% profits, don't watch that video. Okay, do watch it if you feel like it for learning, but that's a guarantee you shouldn't be believing. It's too good to be true. It's really, really hard to build models that can predict stock prices, and most of the videos are like that. So when you use data science tool, when you listen the word AI, approach with caution, engage a person or a team who specializes in this area and share your expertise of markets and then work together. Don't get into the habit of, let's use machine learning and we'll get something out of it. Extremely unlikely to happen. If you have succeeded, great. It means you have put an effort from the starting of the process and you have chiseled something really nice. Again, one small checkpoint: if you have stayed with me for so long, please hit subscribe button, put a comment, like it, share it. It would be amazing to have this video spread across the people that it should reach. And yeah, let's move forward. Now comes the trading strategies, right? Once you have filled and figured out the trading strategy part, you could move on to the risk management. Now again, machine learning techniques can be used for risk management as well, but typically you want to rely on some sort of a basic rule engine at the very least. And in my recommendation, these should be reusable set of Python classes. Don't have them fixed or hard coded. Have a generic setup for a rule based engine. Put the traditional stuff like entry criteria, exit criteria, your lot sizes, your stop losses, and those kind of things, which are, I'm sure you guys are aware of it. So put those elements in there as a basic class, and then you can always start from there and see what techniques can further help you enhance the rule engine and help you manage the risk essentially. So that risk management is an art and science in itself. There's a lot written about it. Do study it and do share in the comments if you stumble upon great techniques. There's optimization techniques that can help you achieve it. Tons of techniques. Again, this is not a technique video, this is more of a broad video. So the technology element there again is Python and focus on reusability, because risk management is really personal, but the system part of it can be generic enough so that it works across varied number of strategies. For example, let's say you have 3 different kinds of strategies that are play. You could have a core fundamental set of risk management modules built, again by a coder or by yourself, doesn't really matter. And you should reuse them depending on changing the parameters and value. Don't build different complex risk management systems, because then what will happen is you have a system A which is designed in a certain way for risk management, then you have a system B, and then when you eventually go to evaluating them, you have a mismatch, right? So you don't want to be stuck in that state. Then comes the order management and execution. Now this is where you do broker integration. Typically broker integrations are simple. When I say simple, it's basically from the fact that most popular brokers provide good APIs and very well structured documentation. However, it is again important to understand the frequency at which you are operating. If you want to trade at minute level or second level, let's say medium frequency or even high frequency, don't build systems which have a long pipeline, long data processing engine and stuff like that. what will happen is your pipeline itself might take 3-4 seconds to execute, and you'll get a lot of slippages around that. Furthermore, what could happen is if you are relying too much on your APIs, or you have designed your system in a way that there's a data layer where there's a lot of files and you're trying to read the data from there, trying to read the data from API, doing some filtration, applying risk engine, and then executing the trade. By that time, that slippage could happen. So again, from a code perspective, try to design the code with the time frequency from day one or whatever, day five. But don't expect a system that was built to operate at 10-minute, 15-minute frequency to suddenly start operating at second level or minute level. That's a very difficult thing. So this is all from one aspect of technology, right? So this is what we have talked about is, essentially Python. Largely, you could also use R if there are people in C++ would love to talk to them. And then you're talking about some DS and machine learning, and then, stats and stuff. A part which is often missed is most traders, and this is really, really important. Most traders would think that this entire stuff needs to be deployed on some server. And this is the normal term that I hear, a server. And the fundamental, while this is correct, I'm not challenging the fact this is incorrect or anything. What usually happens is there'll be a person and he or she will connect to the server. There'll be module A, module B, module C, and module D. And let's say module D is broker, and this is your data provider. Now, there's nothing fundamentally wrong in this approach. This could really work. However, the problem is, how have you built this is the key. Where is your database? Most people would just keep dumping it on that server. And servers could crash really. I mean, I'm not lying. You could have servers which crash. And given the number of server providers, cheap server providers that are there, there's no guaranteed of anything like that. This whole server could go for a toss, and then you'll be having a long debate about my code is lost, falana dhimkana ki sab kuch chala gaya. तो वो बचाने के लिए it is important to design the system. What you could really easily do is, let's take a look at algo trading system. Just for fun, Google it. You'll find tons of different images. This is a very common image. I think I've been seeing this from EPAT and all. Now, most of these systems talk about from a logical perspective. What I fail to understand is nobody is talking about the cloud aspect of it or the execution aspect of it, which is not a good idea. Yeah, this is one element which I found. Let's add the word cloud and see what we get. Yeah, so this is a good image. I was not familiar that AWS has something, but let's take a look at this. So they are talking about it from different perspectives, that there's a market data adapter, as I was saying, there's an algo engine, as I was saying, exchange broker, and data storage part. Now, if you see some of the points which even AWS is highlighting, I hope this is from AWS. Yeah, there's an AWS logo, so I'm just gonna assume. And then there's, yeah, this is also something which I'll want to talk about. So then there's the different components. Focus on this part, right, which is the data storage. They're talking of different areas for storage of historical data, trade, strategy, performance, and stuff. Now, this is really critical, and you can see this, that how many different kind of services it's talking about. Now, there's not one single server. Now I'm getting more deep in the tech. So AWS SageMaker is a service which is really machine learning data science centric. Then there's code commit, where all your code stays in case of any changes, version control, and all of that management. S3 buckets, where your historical data, models, strategy details could stay. Containers, where your core strategies are there, your data preparation stuff is there. ECR, which is container registry, where everything is registered, and then backtesting and training engine. So there's a lot of cloud components involved essentially that AWS is talking about. Furthermore, this is even a bigger image from AWS. And if you see, it's talking about different services. S3 ho gaya, Athena ho gaya, Event Bridge ho gaya, Lambda, DynamoDB, tons of different services. And all of the things that we talked about are talked in form of 8 to 9 services. Now, what are services on cloud? Like you think of a server, think of it as, a server is a type of service, and there's different services like database is a service. And then there's a granular service for each. For example, if you're operating with serverless options, you have Lambda. If you're working with events like market data and all, Event Bird is good. And these systems and softwares essentially help you scale. Now, if you're starting out, if you're completely new and young, you're trading with a couple of lakhs of trading stuff, then I would suggest to do a little bit of version control on your code, do GitHub and all. Keep it on a server, keep taking regular backups, you should be good. But if you're going anything beyond it, right? If you're trying to build a couple of people, you're trying to manage, let's say, tens and hundred, maybe tens of lakhs or a crore or 10 crore value. So what you have is a really high stake, and you don't want your system to fall down on you. And henceforth, this conversation, it was really important. Now, what I could do is, if there's enough demand, we could get into details of what these services are on AWS and talk a little more about it in the next video. I already feel this video is very long. I think I'm talking for about 15 minutes or so. So yeah, that's the end of this video. I want to leave you guys with this thought that this is how it looks like, or it should look like, and not this if you're doing it, which is, a single server. So between this and this is the journey of understanding the technology aspects of it. And with that, I'm good. Thank you guys for listening. If you have liked the conversation, please smash the like button, comment, share, and subscribe. Bye-bye.